So next up we have Robert Palatnick. He is the Managing Director, Chief Technology Architect for the Depository Trust and Clearing Corporation, DTCC.
Thank you very much, and thank you for having me. I will mention that I am a technology architect, and any of you who have spoken with technology architects know it's very hard to take the microphone away from them in 8 minutes, so don't mind my notes. I'm going to give really just more of a technical level set on the state of the technology and talk about a real-world implementation of blockchain technology that we are progressing on. It's not a proof of concept or a pilot. It's a real-world implementation moving a mainframe application to blockchain that is progressing towards production. But first, who we are, for those of you who do not know, I'm the Chief Technology Architect of Depository Trust and Clearing Corporation. We're an industry-owned utility that processes transactions for the global financial industry. We have processing literally around the world. In the U.S., we do clearing and settlement for the majority of equities and fixed income transactions. We have trade repositories and other post-trade services globally. So we provide services to the industry. We're owned by the industry. We're governed by the industry. To a large degree, we maintain the central ledgers of the financial industry. So why would an organization that maintains financial central ledgers be interested in distributed ledger technology? Our real mission and our obligation is to reduce risk and costs for the industry. And the fact that we have a central depository is just a fact of the way technology has worked for many years. Looking at distributed ledger, we realize that is a new model for lowering risk, potentially a new model for lowering cost, and our board and our management obligated us to investigate it further and see if we could take it forward. In terms of the technology itself, we were one of the founding members and we're on the governing board of Hyperledger, and we've contributed a lot of code, over 10,000 lines of open source code to that community. We're banking co-chairs. We're co-chairs of the banking working group of Enterprise Ethereum. We have an investment in a distributed ledger startup, and we're working with a number of vendors and the entire industry on a lot of different opportunities. The primary project that we're working on that I wanted to talk about in terms of where we are is a re-platform of our trade information warehouse, which is a 12-year-old database of credit default swaps. These are transactions that were originally paper-based in a lot of trader desks in the early 2000s. DTCC created a warehouse, a mainframe-based database for these transactions. The regulators actually mandated that these transactions be put in that warehouse before the credit crisis of 2008, and we've maintained that system ever since. So it is the central book of record, but most of the industry have their own books and records, and as Caitlin mentioned, the entire industry is really a reconciliation industry that does a little bit of financial services and banking. So what we have progressed on is we took this opportunity. It was a system that needed to be re-platformed, so it already had a business case because of the cost of running it on the mainframe. It had an industry that was very enthused and committed to working with DTCC on moving it to distributed ledger technology as a method of investigating the efficiency and capabilities of the technology. And it had a set of very defined standards and attributes for how these transactions can work. So there were a whole lot of conditions that really made it a very suitable use case. We have investigated numerous other use cases within the financial industry and within DTCC, and actually discarded them because they would actually add cost, add reconciliation, or the technology is just not ready to handle the different volumes. So some of the lessons learned and where we are. We're started development in February of 2017. We're going to complete development by the end of this quarter. So by the half of the year. So the project is progressing. It will have taken over a year. We have succeeded in making complex financial transactions work in smart contracts. We have succeeded in proving that we can implement a distributed ledger in the cloud, so we are using cloud technology, and integrate it with on-premises grounded solutions for reference data, for some of the capabilities that it needs to integrate with in terms of messaging, so receiving trades from our members, putting them into this database, validating them within smart contracts. So we're verifying that all of that is indeed possible. We're going to complete development by the end of the half, and we expect to be in production by the beginning of, in the first quarter of 2019. And when we go into production, that means over 1 million active positions move into production, tens of thousands of life cycle events for credit default swaps, including payments, terminations, credit events. All of those move into a production system that's built on top of distributed ledger. In the very first phase, we're having internal observer nodes, but in future phases, firms will be able to take down nodes and integrate those into their own ecosystem and platform, and then we expect to add other asset classes into this ecosystem. So this is the way we expect to drive industry value. The other side of it, and this is the reality check, is this is really, really new technology. Sometimes things stop working and you can't figure out why they stopped working. Everything is a smart contract in this technology, and deciding what to put in the smart contract and what to leave off-chain or out of the smart contract has real design implications in terms of performance, in terms of how this works. We are working with a number of different vendors, and Anil mentioned it earlier. Every vendor has their own proprietary implementation. It's proprietary in terms of how it does certain security components, proprietary in terms of their privacy models. And if this is going to be an industry-utilized chain, distributed ledger chain, consensus chain, I think it was referred to earlier, that interacts with other chains for payment mechanisms or other asset classes for potential future trading and settlement, it needs to eventually have interoperability standards where it can interoperate with those other chains. There is no definition for what a smart contract language is. There's not even really consistent definition on what a smart contract is. Inside of some of these languages themselves, some of the most well-known languages in the open source community, there's no decimal points, there's no capabilities for basic transactions. You have to build holiday files, all the things that you take for granted that are in your libraries today, you have to build those from scratch. So all of those have real implications in terms of the time frame and the amount of cost that you have to put into this project. And then the basic development tools are very nascent. They just barely exist, and every now and then the application just kind of stops running and gives you this message, out of gas. And you have to guess, what does out of gas mean? It's like that old pop-up screen that you used to get on your Windows stopped working. And then your developers and everybody just all look at each other. So the positive is we are progressing. We believe that we are going to complete development on schedule. We're going to go into production. The challenge is that this technology is still new. It's still beginning to mature, and we are really working actively with the industry on figuring out how we can make this a viable platform for the future industry, future financial industry, and all industries. Thank you.